Hi, I'm Ling. Welcome to my showcase video. This project features my sound redesign and implementation for Stacklebot using Fmod and Unreal Engine. In this video, I will walk you through the blueprints I created, some of the design ideas behind the sounds, and how I brought them to life in the game. Let's start with a quick walkthrough of the final result. First, let's start with the dynamic footstep system. In Stacklebot, the player walked across various surface types such as concrete, grass, sand, pebble, rock, and metal. To reflect these materials acoustically, I used physics materials in Unreal Engine to define each surface. For timing the footstep sounds, I used animation notifies in the animation timeline to trigger sounds at the correct moment. These notifies send signals to the blueprint system. Then I used light trace from each foot to detect the surface type directly underneath the character at the moment of contact, like this. Finally, using Fmod, I set the surface type parameter to switch between different footstep sound variations based on the material detected. This way, the audio always responds dynamically to the character's movement and the environment. Next, I will go over the robot's core movement sounds, which includes jump, land, reach arm, retract arm, and jetpack hover. Just like the footstep system, I used animation notifies to mark the exact timing for each action's sound cued. I triggered the sounds directly inside the animation blueprint using these notifies. As for the jetpack, I handled it in the robot's blueprint. When the jetpack is activated, it starts playing a looped sound in Fmod. I added a branch to check whether the jetpack is still active. If it stops, I use set parameter to control the jetpack sound and transition it into a power down state. This power down effect is done by simply adjusting the pitch in Fmod, creating a subtle yet effective sense of engine winding down. Interactive object sounds. Stacklebot has many interactive objects, and while designing their sounds, my goal was to give players clear audio feedback while keeping the sound style cohesive, cute, sci-fi, and fun. Let's start with the spawn pad. Every time the player steps on it, saving effect is triggered. I added sounds at the activate and deactivate spawn pad nodes in Blueprint, with the do ones to prevent repeated triggers. I also made sure to stop the sound on deactivation. The spawn pad also spawned a robot. I made the sequence to play the print new robot sound 0.2 seconds after the deactivate robot call. This timing made the animation and sound feel more connected. Next, buttons and pressure plates. For buttons, I added a sound directly to the press button event. Pressure plates play different sounds when the player steps on and off the plate, giving a clear sense of interaction. The elevator sound starts when it begins moving, either up or down, and stops when it reaches the destination. At the endpoint, it plays a distinct stop sound. I also use the elevator's height to set the pitch parameter in Fmod, so the sound subtly changes as the elevator rises or falls. The fan combines a blade rotation sound and wind sound. When the fan stops, I fade out and change the pitch for a soft wind down. The logic is similar to the elevators. Start and stop triggers control everything. For the door, I imagined something air-sealed and heavy, so I emphasized that air pressure sound on opening. In Blueprint, I just added play sound nodes after the open door and closed door events. The crate sound was based on collision. I added a collision box and used event begin overlap to trigger the sound. Do once prevents repeat triggering, and I calculated the component speed to scale volume, so faster impact sounds louder. The stomper was straightforward, just added a sound event after start stomper. For orb emitters and collectings, I placed Fmod audio components directly in the orb's viewport, enabling override attenuation to control audible range. I then used getOrbAmount to set the parameter, letting each orb sound different depending on how many you've collected. Finally, the bushes, since they were placed using the foliage tools and not blueprints, I handled the interaction from the robot's blueprint. When a hit event occurs, I check if the foliage hit is SM bush. If so, I play the rustling sound. Next is the occlusion system. In Stegobot, I placed some indoor sound source like radio, some lamps, and also outdoor factory noises. All of these have basic attenuation settings, meaning their volume changes depending on how far the player is. But if a sound is coming from behind the wall, it shouldn't sound just as clear as when it's in front of the player. So I built a simple occlusion system to simulate obstruction. In the blueprint, I use getLocation to calculate the distance between the player and the sound source, and then perform a line trace to check if there's any obstacle in between. If the trace hits something, I set parameter in Fmod to enable a low-pass filter, making the sound feel muffled, just like it's being blocked by a wall in real life. Next, Tunnel Reverb Zone. In the showcase level, I created a tunnel area to demonstrate environmental reverb. I placed an audio volume box in a reel and used Fmod snapshots to apply reverb when the player enters the tunnel. Once inside the box, the player hears extra reverb effects that simulate the echo and spatial feeling of a real tunnel. Ambient sound transitions. In the game, the environment is divided into indoor and outdoor areas. I placed a large trigger box for the indoor zone and 3 smaller trigger boxes as exits. I created an ambient manager blueprint that starts playing ambient sound at the beginning of the game. When the player moves between zones, it sets a parameter to adjust the ambient sound accordingly. In Fmod, both indoor and outdoor areas use the same ambient event, but when the player enters the indoor area, I lower the volume and apply a low-pass filter via parameter to simulate a muffled, enclosed acoustic environment. The main world blueprint managed the logic for detecting the player's location and triggering the appropriate parameter changes. That's all. I'm Ling. Thanks for watching. See you next time. Bye bye!